This lesson is on law of sines. In your note packet, it also says law of cosines. We ran out of time, so you can cross off law of cosines because we only are going to do law of sines. Please write down in your note packet the I can statement. I can use the law of sines to find side lengths and angle measures of a triangle. First, we're going to just start with a little warm up, kind of a review of prior lessons. And so it says solve each triangle, find all sides and angles. So the first thing we're going to do is find side RS, which is this side. Then we're going to find side RT, which is this side, and angle T. Well, let's start with angle T actually, because angle T is right here. And we know that since this is a right triangle, we know that this angle is 90 degrees. This angle is 27 degrees. So to find angle T, all we have to do is take the total, which is, we know the total of all the angles added together is 180, and subtract off the 27 and the 90. So 180 minus 27 plus 90 is going to be 63 degrees. So this is 63 degrees. Side RS, well, because it's a right triangle, we know that we can use Sohcahtoa. Sohcahtoa. And if I'm going to call this my hey, look at me angle, because that was our theta that was given, let's start with that. We could say that if we're trying to find this side, which is RS, I would say the side opposite the 27 degrees is right there, and the side adjacent to the 27 degrees is right there, and this is called the hypotenuse. So if I want to find this yellow side RS, I'm going to use tangent. So tangent of 27 degrees is equal to O, which is 12, over A, which we'll call this side we're trying to find. We'll call that X in this case. And so now what we're going to do, if we're solving for X and we have a fraction, we're going to multiply both sides by the denominator. So we get X tan 27 degrees is equal to 12. And then we're going to divide both sides by tan 27. And we get X is equal to. So if we take 12 divided by tan 27, you're going to get 23.55 if we round to the nearest hundredth. So this right here, this side right here is equal to 23.55. And remember, make sure your calculator is in degree mode. The last side that they're asking us to find is, go down here, is side RT. And RT is the hypotenuse. So if we call this our hey, look at me theta angle, I could use, well, I have a couple different options actually. I always like to use what I'm given. So I would use opposite over hypotenuse, which is sine. But now that I have the adjacent, I could also use cosine. Either of them would give us the right answer. All right, so I'm going to use sine. Sine of 27 degrees is equal to O. So make sure we know that this is an O. Opposite, which is 12, over hypotenuse, which is, again, we'll just call this, in this case, we'll call that our x. In that case, that's what we're trying to find this time. And I'll scroll down here. And we're going to multiply both sides by x. So we get x sine of 27 degrees is equal to 12. Divide both sides by sine 27. X is equal to, all right, stay consistent, I guess, with that. And if we take 12 divided by sine 27, we should get, scroll down here a little bit, 26.43 if we round to the nearest hundredth. So what we just found was this side, which is 26.43. So that's a review. You can use Sohcahtoa when we have a right triangle. In today's lesson, in Law of Sines, what we're going to talk about is our other options for when we have triangles that are not right triangles. There we have another strategy for determining sides or angles of a triangle. And what we're going to use today, it's called Law of Sines. So when we're trying to determine what to use, whether we use Sohcahtoa or Law of Sines, if it's not a right triangle, we have to use Law of Sines. Now, back in geometry, you should have talked about Law of Sines. Law of Sines allows you to solve a triangle as long as you know either of the following. We must know this. I'm going to write down the two items we must know. Angle, angle, side, or side, side, angle. And as long as we know one of these, we're able to use the Law of Sines. So here's what the Law of Sines is. Again, the important thing to remember is this. Big A, that's referring to angle A, and the side opposite that is little a, which is the length, the side length of the triangle. Opposite angle A. Same with B, big B, big C, little c. So Law of Sine states that the sine of A divided by the length of side A is equal to sine of B divided by the length of side B equals sine of C divided by the length of side C. So we can use any combination of these to find the other parts of the triangle that we're trying to find. But again, when we say angle, angle, side, what that's referring to is we must know this angle, and this side, or this angle, and this side, or this side, and this angle. That's what that means. And we'll go over an example. All right, let's see. Check each triangle to determine if the Law of Sines will work. Verify that you have information that will work to use the Law of Sines and state why you are unable to use Law of Sines. So when we look at this first triangle, it looks like it gives us all the angles. Angle, which would be angle, angle, angle. And so therefore, we cannot use Law of Sines because we need to know at least one side length. So we should write, cannot use Law of Sines because need to know at least one side length, and we don't. So we can't use Sohcahtoa because none of them are 90 degrees. Let's go over to this example. All right, so on this example, we have a side, we have an angle, we have an angle. So let's see. There we go. It satisfies option number one, angle, angle, side. angle, angle, side. So we have enough information to go off of to finish finding the other angles and sides. So again, I'm going to label this little n, label this little l, and label this little m. And so, first of all, I can find the missing angle because we know the sum of all of the angles in a triangle is 180. And if I subtract off the other two angles that I know, we have 180 minus 56 plus 56 is 68 degrees. So 68 degrees is that angle right there. All right, because that's what we're trying to find here. We're going to try to find all the angles, which in this case it was easy because we're given two, so we know all three add up to 180. Now let's find our missing side. All right, well, let's start with, again, we know this side. So I'm going to start by saying sine of 56 over this length, which is 26, is equal to, because again, I have to take the sine of this divided by the length of the side opposite that angle. And let's find n first. So then I would take the sine of 56 divided by n. Remember, there it is. There's what we can use. All right. Well, when I look at this right now, what I'm going to do in this case, I'm going to I can cross multiply. So this times n is n sine of 56. And this times this is 26 sine of 56. I'm solving for n, so I'm going to divide both sides by sine of 56, sine of 56. That cancels, that cancels. So n is equal to 26. So we found this side. So let's see. We know all three angles. We know the length of this side. We know the length of this side. We now need the final length, which is side L. Well, I'm going to start back with my given. And again, it doesn't matter because all of the sine of each of the angles divided by its side are all equal to each other. All right, so what I can do right now is I'm going to scroll over here and I'm going to change to blue. And click this to keep this separate. There we go. All right, so again, let's start with sine of 56, this divided by this. And now I'm trying to find side L. So now I have to take sine of 68 divided by L. Cross multiply, I get L sine of 56 equals 26 sine of 68. Divide both sides by sine of 56, sine of 56, and I get L is equal to, well, if I take 26 sine of 68 divided by sine of 56, I'm going to get 29.08, round to the nearest hundredth. Type this in our calculator and be in degree mode. And we found all the missing angles and sides. All right, let's do another example. Let's do example 1, and then we're going to save 2, 3, and 4 for class. All right, well, the first thing I'm going to do, I know I can't use Sohcahtoa because it's not a right triangle. I always look for that first. I can find my missing angle by taking 180, because that's the sum of all the angles, divided by the 29 plus 50. So that's 101 degrees. Right there is 101. All right, let's label this. I'm going to call this A. I'm going to call this B. I'm going to call this C. I could have went the other way around. A, B, C. It doesn't matter. So I know, though, the side opposite angle A is A. The side opposite angle B is B. And the side opposite angle C is C. That is critical and important. All right, so let's start with what we know. Another thing we knew we could use a law of sines is because we were given angle, angle, side. We go back, angle, angle, side. And notice it's because this angle is next to this angle is next to this side. So yes, law of sines is going to work. All right, so let's start. Sine of 50 divided by, actually, I can't do that. Let's start again, please. I want to start with the side that I have the angle and the side. I know the side length. So sine of 29 divided by 26. All right, let's find B first. Is sine of 101 over B. Cross multiply, I get B sine of 29 equals 26 sine of 101. Divide both sides by sine of 29. Sine of 29. And B is equal to, so if we take 26 sine of 101 divided by sine of 29, just have to double check something because I labeled it differently when I did my work here. So 26 sine of 101 divided by sine of 29 is 52.64. Rounded to the nearest hundredth. So this is 52.64. And now we only have side C to find. So again, let's change my color. Let's start back with my starting point. Sine of 29 over 26 is equal to sine of 50 divided by C, right here. Let's cross multiply. I get C sine of 29 is equal to 26 sine of 50. Divide both sides by sine of 29. C is equal to, so if we take 26 sine of 50 divided by sine of 29, we're going to get 41.08. 41.08. So when it says solve each triangle, that's what it's asking us to do. Find all the missing angles and find all of the missing sides, which we did. The rest we'll do in class.